In this question, you're supposed to express in sigma notation and then evaluate them. First part is ln 2, ln 4, ln 8, ln 16 and so on until ln 2048. So you realize that it's actually powers of 2, 2, 4, 8, 16 and so on. And you'll find that we need the result ln x power n is n ln x. You can remove the power, you can move the power down. Okay. Let's look at the solution. First we observe that 2 is 2 power 1, 4 is 2 power 2, 8 is 2 power 3, 16 is 2 power 4. Continue this way, 2048 is 2 power 11. So which means you can rewrite it as ln, in this case you can read ln 2048 can be written as ln 2 power 11. So every term you can rewrite it as ln 2 power something, ln 2 power 1, ln 4 is ln 2 power 2, 8 you write it as 2 power 3. So which means every term is of the form ln 2 power I. And this is A1, A2 until A11. So which means you can write it in sigma notation as summation I from 1 to 11 because there are 11 terms. Each term is of the form ln 2 power I. So we can give this as an answer to first part. As to put it up, right? Remember you're supposed to find the answer. Next we look at the second part, how to work out the answer, how to work out summation ln 2I, I from 1 to 11. So first we take note that ln x power n can be written as n ln x. So you can bring the I power I down as I ln 2. So that's why summation ln 2 power I can be written as summation I ln 2, I from 1 to 11. And then you take note that ln 2 is a constant. So ln 2 is just a number. So ln 2 constant. Ln 2 is a constant. Constant can be written outside. So you can actually write it as ln 2 means summation I from 1 to 11 I. So this will be same as ln 2. Okay. So before that, maybe I show you constant can be taken out is in the lecture notes. Here, slide 19. If you have a constant alpha, beta, you can write it outside. So you are making use of this result. Okay. And the next step is to work out the summation I from 1 to 11. You sub I as 1 is 1. You sub I as 2 is 2. So it's 1 plus 2 plus 3 until 11. So this is actually AP. You can take it as an AP first term 1, common difference 1. So you're adding 1 to 11. So you take it as an AP first term 1, common difference 1. So the sum will be n over 2, 11 over 2, and first term plus last term. And then you get this, right? You get this part, then times ln 2, because ln 2 you have written outside. And this part add up to be 66. So we are making use of the formula as n is n over 2 first term plus last term. So just sub n is 11. Okay, so that's how we get final answer 66 ln 2. Let's go to the second part. For the second part, right, you have to check. You'll find that numerator is powers of 5. We have 25, 125, 625. So all these are powers of 5. So this one is actually 5 power 4. 125 is actually 5 power 3. And 25 is 5 power 2. 27 is 3 cubed. 3 square. So likely it to be a GP. So we just have to check. So this is whether it is a GP. A1 is 3, A2 is 5, A3 is 25 over 3, and so on. So if you take A2 divided by A1, the answer is 5 over 3. If you take A3 divided by A2, right, then is 25 over 3 divided by 5 is also 5 over 3. So you can do it for a few more terms, a few more, like A3, A4 over A3 and so on. You realize that it's always 5 over 3. So this will give you a GP. So that means it gives you a GP, R is 5 over 3. So this will become a GP. So this is a GP. First term is 3. Common ratio is 5 over 3. And then what is AN? The formula for AN is A R n minus 1. A you sub as 3. R is sub as 5 over 3. So it's 5 over 3 power n minus 1. You're adding this to 2n term. So it means you get A2n. A2n, you just replace n by 2n. AN is 3, 5 power n minus 1. We just found AN is 3, 5 over 3 power n minus 1. So A2n will be just 3, 5 over 3, then 2n minus 1. You just replace n by 2n. So n, you just replace it by 2n. You get a formula for 2n. So we get the summing A1, A2 until A2n. Right? So the answer should be summed from 1 to 2n. Then your formula for AN is 3, 5 over 3 power n minus 1. So it means AI should be 3, 5 over 3 I minus 1. You should write this as you're adding A1, A2 until A to n. Okay, let me repeat this here. You're adding A1, A2, you're adding in part B, you're adding A1, A2, A3 until A to n. It means you sum from 1 to 2n, AI. You sub I as 1, 2 until 2n. Okay, then the formula for AN is 3, 5 over 3 power n minus 1. And because you're looking at AI, we write it as similar notation. Instead of AN 3, 5 over 3 power n minus 1, you use AI as 3, 5 over 3 I minus 1. So it means you should write it as summation I from 1 to 2n 3, 5 over 3 power I minus 1. So that's how we get this part. And this part basically, you wrote a GP and you write S2n. And remember the formula for Sn is A 1 minus R power n over 1 minus R. A is 503, right? R is 503. So you sub inside the formula for Sn, but instead of n you use 2n. That's why here is 2n. Here is 2n because this is S2n. This is actually S2n. Okay, and after that you just need to simplify this into this final answer.